Hi, I'm Jonathan and welcome back to Software Design from the Beginning. In this episode, we're going to go back to the beginning, again, episode 1, 2, 3, and we're going to look at the box, the line, and the conceptual layers, and add a little bit more meat to the bone. Right, let's get started. Here we have the list that we've been building from previous episodes. I'm going to move that to the side, and we're going to start straight away looking at conceptual layers in a little bit more detail. We're going to zoom right out and then hopefully go back in all within 10 to 14 minutes. Let's see how we do. So, what do we call this? Well, let's call this the real world, right? Here it is, the real world. How we look at things in this real world is going to be slightly different. Each one of us is going to have a subjective view on the real world. It's amazing how different our worldviews are, but let's say that the real world is any interaction in our worldly system, right? Any economic, any biological, any system. This is the real world in which we operate. If I draw another box underneath, I might say, well, within that real world we have systems. And these systems are, perhaps a little bit more tribal or geographical. There might be teams. I'm trying to keep this software development, so let's say that this is the real world for business and the domain and the software that it exists within, and this system is the system that you're building, right? Let's bring it down. Okay. Hopefully, by the previous explanation, you can see how conceptual layers can go all the way out into philosophy. So if I take a system like this, I might say, well, a system is divided up into subsystems. And if I have some kind of architecture, which everyone's going to have, whether you've designed it or not, you will have a resulting architecture either by accident because you've just designed something like that, but usually because you're sitting on top of another platform that subscribes or prescribes a given architecture. If you're in the Java world or the .NET world or the Python world, there's going to be, based on the dependencies and what you do and what kind of projects you begin, that is going to dictate to a large extent your architecture. So there we have that. Now, if we go further down, we're going to look at architecture. Well, what is architecture? We'll look at that in a future episode. What I would just like to do now is say that the architecture is divided up into components, and then a little bit further down here, we're going to say presentation of some kind. This is your app presentation. And then we're going to say, well, there's something underneath, right? Maybe data. Let's say that it's data. Okay, so this is just my brief, unscripted version of conceptual layers as we move down into the system. Let's analyze this a little bit more and see what we're doing. I want to point out where we are and how we think. Let me change the color over there. Let me change the color over here. Okay, so typically, I'm talking typically, what happens is that this here is decided for us. It tends to typically be decided for us. Let's say we're using .NET. We might be building a web application. The web application has an architecture. That architecture being used perhaps is MVC.NET, their sort of flagship web-based framework. And within that architecture, we are now using MVC. This architecture has now been dictated. And if we read some books and sort of figure out what we might do with the rest of our application, all the complexity and change management and all that we're going to need to look after in our future, we're really starting from this point. We're starting from this point. So when I say components, well, let's get a little bit more real. What we might do over here is create layers. This is a very, very typical thing. The layer architecture. So even though MVC might be here, prescribed for you, you probably will find that you have some kind of layer. And that layer could be, architecturally speaking, because of yet another modern craze, you might have some kind of API. or some service-oriented architecture, and then you're sitting with something like this. Now, if you have layers, you might find that within those layers, let me make that a bit smaller, within those layers we are going to be looking at the typical sort of layer architecture, and then we're talking about presentation, we're talking about business logic, like that, and then we move down to the data. So I've kind of drawn it over here. If you think about it with the components, I just really think of components as something different. Let's do that. Let's call it in line with the API over there, and then we have some kind of presentation and data. So this layer can be as thick as you want. You can divide this layer up into 2 or 3 or 5. You could have a services layer, or you know, something that's called an API, microservices, any sort of layered thing. But what is the commonality here? The commonality really is that when you're dealing from this point to this point, the stuff in between tends to be what people are kind of looking at. They're looking at, you know, perhaps sort of like a multi-tier, n-tier, load-balanced, multi-server, that kind of thing. So we're looking at tiers. And because we have tiers and we need load balancing, and because of cloud and things like that, we might have this kind of dictatorial kind of architecture taking shape. Okay, I hope you can see that this is very, very typical in our world of programming and software, business especially right now. Okay, what I failed to mention here, which is just as common, is that we tend to sit on some kind of framework. And I'm going to draw it here separately because the framework is possibly a UI framework or some other. Now, if you look at this blue area here, these areas here have been somewhat reduced or defined. Real world, well, you know, ambiguous, depends on your domain experts, who you're talking to, what application you're doing, the context, the scope, what your boundaries are. Your system, obviously this encompasses everything that you're doing, the entire system, and any subsystems you might have. If you think of subsystems, well, subsystems really go across. You might think of a subsystem there as your layer, perhaps. You might have another system under API, so it might, you know, or with your tier, it might be a separate system. So systems can be a little bit vertical. Okay, right, so I'm not going to leave that there because it makes it very complicated to look at. The point I'm making here is, as we go down, there is a separation between what has been done for us in terms of the platforms and the architecture and the requirements that seem to come in on these green areas, and then what we do as software architects and developers within our business application. The problem is that if I had to scale the kind of effort, the complexity, the rules, business rules, validation and all that, and give it a percentage of workload on either side of this fence, with 20% and 80% in terms of complexity and business validation and rules and things of that nature on that side or that side of the fence. This is Pareto's law. So if you think about this side of the fence has 80% of the complexity. We're talking business rules, validation, reporting, architectural decision, tiers, clouds, configurations, continuous deployment, all of your tooling, dependency management. We're talking all of that kind of stuff. And it's being dictated by a prescribed architecture that says MVC is the only way to conduct this. The framework uses MVC. Your server side uses MVC. Your client side frameworks use MVC. This is it. Well, it's not enough to manage the complexity of large projects. And this is probably the primary reason why projects fail in the entire evolutionary progress, complexity management, change management, evolution, emergent design, and so on. This is why it fails. We need to manage these things in a whole new way with absolute focus on complexity, dealing with complexity in the long run. So let's have a little sort of rundown on this kind of conceptual world quickly, but we're going to dive in. We're going to dive in closer here to where we feel we sit. The first thing is that these influencing architectures, right, these architectures that come our way, that force us to use cloud or tiers or layers in a certain way, we need to address that. But that's probably as an industry. I'm going to leave that out for the moment. There will be a video, and of course you can check my alternative series, which is Designing for the Future, which addresses architectural decisions and architectures designing for the future that addresses this kind of scenario. What we're going to do is go a little bit deeper in here now. So in this world of layers, APIs, tiers, cloud, to simplify, I'm going to reduce it to layers. And the layer, I'm only going to sort of think about this in an MVC kind of way, that you call something and that something calls the presentation and then calls data. I'm going to slip in the business layer here because it seems to be pretty standard. So in this kind of scenario, in this architecture, what we're really talking about is messaging. We have to discover what is the message that we wish to send from this layer down into the bottom layers. So what we're talking about here, let's write it down. We're talking about input and output. And the input-output is going to be a message that travels down the layer and then pops back up again. Now the layer going in, the message going in, is going to be dictated by the scenario, the context of the application at that moment. And what is coming out is going to be dictated probably based on user experience and a message of data, presenting data, and understanding what any errors there might have been. So in this kind of scenario, what we're talking about, are we designing the correct modeling, right? Are we modeling the correct data? Are we deciding on sets, graphs? What are we doing with this data as it goes down and as it pops back up? What is the encoding of the message? Well, we know that HTTP is a very, very likely message that comes in, JSON, XML, or other kinds. So these are messages that come in, and somehow we need to convert this message as it goes down into the database and pops back up again, and delivering a message to the end user. Now, this is a very basic form of messaging. There are others, and we'll briefly go through that now. What if you have two servers? And the two servers, they call each other. So what's happening is we've got something, a message coming in here, and it's actually hopping from there, and so the return message is the input for this layer. And that's also something we have to consider when we're designing.